And now we're happy to address any questions you have about data science and predictive analytics. You can think of this as the free consulting segment of our webinar. Access to our advanced analytic gurus, senior consultants Keith McCormick and Scott Terry. Each question you submit will receive multiple perspectives. We do have, like I say, a few good questions coming in right now, but there's room for a few more for the remaining 20 minutes we have until we wrap this one up. So just enter your questions into the webinar panel. I'll be pleased to read them aloud for myself, Scott, or Keith to respond. Let's start with the first question. Fantastic question from Mitt. Mitt asks, do you have any tips on how to change the culture within the organization around embracing change in analytics? So I usually get greedy with these. I have two parts to this. I'll start with one. I'll refrain on the second part until Scott and Keith have the opportunity. And I'll start with this concept because I don't think it'll be robbing from the others. That one aspect is you may not be able to change the culture within the organization. And there was one opportunity that we worked on where we found that there was a lieutenant to the organizational leader who was essentially in charge of leading the overall team, and we found that she was essentially a black knight. The owner of the organization really wanted to make the investment, was purposeful in approaching analytics, but the lieutenant kind of wanted to prove that this was a bad move, and it was kind of cancerous to the overall approach. So that was not the only thing that held them back, but a comprehensive assessment can find a number of yellow and red flags that sometimes are very important to point out before you go ahead with an implementation. And those are good things to uncover upfront before you go ahead to make substantial investments in building a team, in investing in software licensure and other expensive ventures before you head down. So I'll skip the other part until the end. Let's go ahead next to Scott. Scott, what else would you say to Mitt about any tips on how to change the culture within the organization around embracing change in analytics?
Well, I think that's a great question, Mitt. And to springboard off of what Eric had just said, you know, one of the first things that we need to do when we do any type of project is to define the problem set. And the problem set regarding your culture. You know, anytime you want to make a sale, you have to remove the barrier to sales or the objections. You have to be able to counter those. But before you can counter them, you really need to know what they are. Once you do that, then nothing succeeds like success. So I would look for a problem on my own time, perhaps. Well, not perhaps, probably, because you don't want to put yourself into a bad situation if you have to take your own regular work time to do some work. But find a problem that's looks like some low-hanging fruit that you could tackle. Invest your own time in it and present the results. If you've got something that's concrete, that looks good, that you can quantify in terms of a measurable objective, against a measurable objective, and you can show some impact and you can do it cheap and on your own time, it's pretty hard to ignore something like that.
Great advice. Thank you, Scott. And Keith, I'll admit, Mitt submitted his question before your portion of the webinar. I know you touched on some points pretty close to this. So Mitt's question did come in earlier, but there may be additional ways to round it out.
Well, I agree that a couple of the comments that I made, you know, earlier kind of bear on this a bit. But I think I guess there's two, and they're closely tied to each other. One is that if you think of predictive modeling as a cost center as opposed to a profit center, then you're going to get into you know, a little bit of trouble, because then you're going to be gun shy about having projects that might run several weeks. But if each project is self-financing, then you don't have to worry about the fact that a project might run several weeks. And then related to that would be sometimes you get some analytics talent in-house. Sometimes they're new hires, sometimes not. And since there is an endless supply of routine reports, ad hoc reports, and so on that have to be done, you think, gosh, it's not going to be a big deal if I just borrow some of this modeling talent temporarily, or so you think, to help out with ad hoc reports and routine reports. But once they get on that treadmill, they usually never get off. And if they were hoping that their role was going to be building predictive models, even though those other kinds of activities bring value to the organization, they're going to get frustrated, and then you're going to have a retention problem. So those are the two that are up at the top of my list.
Terrific, yeah. And I promised to round out with one more idea. Actually, I formed it into two, but the one idea is certainly education, and there are, the TMA certainly has a course that is specific to leadership, and also has short sessions that we can convey to really uncover the potential of predictive analytics when it's approached properly, as well as risks and rewards and the like. So education is another way, and then kind of touching back to both Keith and Scott. Even exploratory analytics, before you even get into the predictive, oftentimes reveal things that the organization didn't realize previously. We've had that happen many times. We're just doing the exploration, comes up with some very interesting insights before the predictive is applied. So those are a number of tips, Mitt, that's hopefully helpful to you with gaining more people, getting more momentum to help embrace the change and level expectations around approaching analytics. Next question comes from Elias, or it might be Elias, pardon me for pronunciation. How can very big data sets of millions of rows be analyzed and visualized? So kind of getting into the volume part of big data, bridging into analytics. Let's start this time with Keith. What can you tell to Elias about how can very big data sets with millions of rows be analyzed and visualized?
Well, it's really a moving target, isn't it? How we define big. Almost 4 or 5 years ago, I was on a retail project for a major retailer, and we were doing what we called a market closet analysis. So in other words, a lot of people have heard of market basket. The whole notion of market closet is that it's not just stuff that you purchased on one day. You might have purchased it over the course of an entire season. And I had 40 million basically receipts on my right on my laptop. I wasn't on a server. There was no Hadoop, nothing. And that was a while ago. So you can be in the low tens of millions, and you really don't have to do anything any differently than what you might be doing with 100,000 rows or 500,000 rows. Now, granted, when you get into hundreds of millions of rows, you're into, or billions of rows, presumably, you'd be in a different kind of a situation. It just physically won't fit. But what people often forget is that you can prototype on a sample. Because, I mean, think about it. Just common sense will tell you, what will 500 million rows tell you that 30 million or 50 million won't tell you?
Right.
What will 80 million rows tell you that 2 million rows won't tell you? So again, there's a lot of techniques around the truly huge data sets, but I think most people probably, unless you're LinkedIn or Facebook, or unless you're involved in Internet of Things, I think most people have fewer than 10 to 20 million rows, and they might have a lot fewer. One more quick thing about this that a lot of people forget as well. Sometimes people forget to take the irrelevant data out. There's an example that I use all the time. I was doing a cell phone churn project, and there was a code for a very rare kind of churn activity. And at the risk of being morbid, it was CD. It was customer deceased. Now, of course, that's not commonly the reason that someone churns, but it does happen. Well, you're not going to offer a promotion to someone that has churned for that reason. So we often forget to take out noise in our data that's not relevant to the problem. And that can be 10, 20, 30% of our data. So even if you have 60 million rows, you may find that you really only have to analyze 35 million, and you'd be fine on your laptop. And I have a feeling that these numbers are huge compared to what most people on on the webinar have today. So if you merely have 1 million or 2, or 100,000 or 2, or 50,000 or 100,000, then that's absolutely no problem.
That would be, and that's a great example. Even though I think that that exercise would have been far more difficult because trying to remove all the deceased would be a huge undertaking. And with that terrible pun, watch the mass exodus, right? All right, we'll head over to Scott. And Scott, anything to add? And I, I guess the key point, we'll want to make sure, we understand essentially the dynamics of the solution space. How many vectors do we have? Do we have enough data points to adequately represent the solution space? And I've seen formulas in the past that kind of suggest how many data points you'd want to include. Some rough formulas, they're always rules of thumb. Do you have any suggestions around sampling the data so you get an adequate representation of the solution space without having to include, so many cases for training?
Is that a question?
It didn't sound like it. I know my questions often sound more like a statement. But do you have advice on how to sample the data when you've got huge amounts of data? Do you have advice on how to sample it without, sacrificing a good representation of the solution space?
Well, yeah, I got an answer for that. But before I ever jump off into any of that stuff, I'm assuming because the way the question was asked that it's not a question of whether you've got that much data or not. You probably do. You wouldn't be asking the question about it. Before I start thinking about algorithms, before I start thinking about, what type of software I'm going to use, where I'm going to store the data, how I'm going to sample it, I got to have a problem. If I don't have a problem to analyze, then you're pretty much just, I'm trying to not use a term that I usually use. You're kind of spreading liquid into the wind.
I wish I could translate that.
I honest to goodness, I had a client one time who came to me and said, "We got all this data, analyze it for us." And I kept trying to tell them, what is that I'm supposed to be looking for? What's the problem that we're dealing with? Tell me some of your pain points. And guess what? When we don't know what we're looking for, we're not going to find it. So I kind of tend to look at that question just a little bit differently. All the software, all the storage, all the sampling, all that stuff's secondary to actually having a business problem that the data can solve. If you don't know what the question is, you don't know how to answer it.
Well, and that leads, directly. I think that's a very related answer I think you're going to have to the next question, which is around algorithms. There's so many algorithms. How do we decide which ones to apply? Is there a good resource that explains each algorithm's pros and cons? I mean, we go through that in the model development course a bit, and there are trade-offs. There's trade-offs between accuracy and explainability, for example. But you need to rise up. Before we're concerned about algorithms, this is almost like having a whole bunch of mechanics working under the hood. There's ways to make the engine run faster, better, smoother. But if we don't understand the conditions of the racetrack, if we don't know the rules of the road, if we don't know what it takes to win the race or what the rules of the race are, then you're going to be taking that engine that you tuned up and running off course at a higher rate of speed. It doesn't get you there organizationally. Now, having said that, let's start with you this time, Scott. Let's pretend we've done all of our homework up front. We understand leadership's motivations. We understand a lot of what we need about the environment and how we're going to deploy, how it's going to be operationalized, the makeup and the construct of the team. We've done all those things. I'm going to assume that we're allowed to jump to chapter 5 of the book. And when it comes to algorithms, then, what are some differences between some of the machine learning algorithms that we can answer to the question about pros and cons of some of the basic ones? What would you say, Scott?
Well, the first thing I would look at is, what am I trying to predict? If you think about number scales and number theory, you're either trying to predict a number or you're trying to predict a state. a status, probably is a better way of putting it. If you're trying to predict who's going to respond to a marketing program, that's like an on and off switch. So we call that qualitative prediction. And there's a whole family of algorithms that are that are available for qualitative prediction. The other side of the coin is quantitative predictions. Am I trying to predict a number? Could be a sales forecast. It could be anything numeric. So you have your first division in terms of qualitative and quantitative predictions, and there's a whole host of algorithms on either side that you can bring to bear. Once you do that, or concurrent with that, then there's a second question that you've got. Am I trying to predict patterns that are already known, or am I trying to predict patterns that are unknown? For example, going back to the classic response type of model, if that's called supervised learning. I actually have some history of people who have received a marketing incentive, and I know whether they responded or they didn't. So I have some historic results that can be used to supervise a training algorithm to create a prediction. Then there might be other situations where I don't have history, and we call that unsupervised modeling. A good example of that is I look out in the sky at night and I see all these different stars in my telescope, and I want to categorize them, but there's no predefined category. So I might use a family of algorithms that are called clustering algorithms to group similar types of stars or objects or people or animals, like they would in taxonomies. So the two big divisions in terms of algorithmic approaches are quantitative algorithm or qualitative algorithm, and then am I in a situation where I have actual history that I want to discover patterns in and project? That's called supervised learning, as opposed to unsupervised learning, where I don't have any historical patterns that I want to project, but I need to discover what they are.
That's a great way to categorize them and organize that response, Scott. Thanks very much. And I've seen many, before we go to Keith for last word on this around algorithms, that are curious about, the old classic term that they put to it, artificial intelligence or machine learning algorithms, and some of the trade-offs that you have with those. I know that many build ensemble models, or they'll combine modeling methods to overcome individual limitations. For example, decision trees are very good at explaining results. You can trace how it came upon its results. You do need to, as Scott said earlier in the presentation, you must understand the nature of outliers. He gave fantastic advice on how to treat them, but often decision trees don't have the same sensitivities to outliers as other methods do. And then you have neural networks. They're less explainability, more accuracy. They train faster than, say, genetic algorithms, but they can get caught up in local extrema, and genetic algorithms, they're better at finding global extrema, but they're more computationally intensive. So those are a few machine learning methods and techniques with pluses and minuses. So we touch on some of them in the model development class. Keith, what would you like to wrap up around methods, given the strategic context that we're pretending is already in place? Anything to add for methods as we wrap up the event?
Well, you two have done such a thorough job, Eric. You've covered a lot of the bases. What Scott explained is so critical, and it obviously happens a lot earlier than the modeling phase. You have to translate your business problem, which Scott also emphasized, and we all agree is so critical, and you're basically trying to identify what class of problem you're in. But then, of course, as we all know, that still leaves you with dozens of choices. So I would basically say two things about it. I'd say, one, once you've done all that right, which algorithm you choose is not nearly as important as most folks think it is, because you've really won or lost the battle by the time you get to the modeling phase. You know, the differences between these algorithms can be fractions of a percentage point of accuracy. And then the other thing that I would say that you started to talk about, Eric, was this whole notion that some techniques are easier to explain than others. So this brings up the so-called black box technique. You know, some techniques are opaque enough that they're hard to explain, and that might rule them out for certain applications. Let's say like insurance. If you have to go to the commissioner of insurance and explain why you set certain rates, then a black box technique isn't going to work. But you know what's funny about this is quite recently I had someone ask me, said, you know, Keith, you were just talking about an example where you had used a cart, which is a type of tree, and said, does anybody really do that now? Isn't everybody doing gradient boosted trees, which happens to be one of the hot algorithms this year? Well, gradient boosted trees are very powerful, but they are black box, so absolutely people are still using some of these techniques that have been around for 20, 30, 40 years. We still use them because every situation is a little bit different. But anyway, in closing, Scott's 100% right. It's about problem definition. It's not ultimately about algorithm.
Absolutely, although it sounds like there's tremendous risk in using an algorithm that's deemed unfashionable. Right? That's great. That's a great capper. Truly appreciate it. And at half past the hour, we're going to draw this event to a close. I'd certainly like to thank our attendees today for your sustained interest and your active participation, as well as Scott and Keith for your great presentation segments and your highly informative Q&A contributions. We'll follow up with an email shortly with some resources and suggestions that will hopefully be useful to you. And from there, we hope that you'll consider joining us at a public classroom or online training event soon. Make sure to go to the website and check out the schedule and details for next month's live online model development course, as well as the full schedule of physical classroom and live online productions for the start of 2017. Now, if you don't have a training budget or your schedule just doesn't fit, but you'd like the guidance of a seasoned mentor like Scott or Keith, you might be interested in the modeling agency's Escort on Call program. Escort on Call is essentially a retainer account that provides remote open access to a TMA senior consultant. Simply open up an Escort on Call account, and you've instantly added a wealth of experience and capability to your existing bench without expanding payroll, administrating complicated contracts, or taking elevated risk on larger commitments. We'll get you the answers you want, guide you through it tactically or strategically, show you how it's done, implement any analytic tasks you may wish to delegate, and then remain on call until the next time you need us. And meanwhile, when we're not actively working, you're not paying a dime. So a link to the Escort on Call description page will be among the resources included in the follow-up email. On behalf of myself, Scott, and Keith, thank you again for attending Predictive Analytics Failure to Launch. Have a very pleasant afternoon and evening, and this brings the webinar broadcast to a close.